Today we're going to talk about the periodic table. We mentioned it a little bit in previous discussions, but we're going to look at it a little bit closer. Basically, as I said a little bit earlier, a row is called a period, and then the columns are called groups. And you have what are main group elements, which are those tall columns on the right and the left. So those are the tallest ones. And then the transition metals are the shorter columns, and then the inner transition elements are those that are at the very bottom, which are we call the lanthanides and the actinides. They don't have groups assigned to them because they don't really follow our rules. So we have a period, so period 1 or 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. And then we have, so that's your group numbers, group numbers, 1A, 2A, 3A, 4A, etc. Your periods are across 1, 2, 3, 4, and so on. So those are your what we call main groups. These that are on the sides that are your taller groups. Then in here we have, these are called your transitions. And we call them transition metals because they are on the left-hand side of our line, if you remember the line that we drew before between metals and metalloids. And then these are our inner transitions, the lanthanide and actinide series. And we don't talk about them a lot in this class because they're radioactive. We will talk a little bit about them at the end. So when we talk about these groups that are the columns, we're going to talk about them kind of as a group because they have similar chemical properties. For example, 1A we call the alkali metals. Group 2A, alkaline earth metals. Both of them are true metals. They're as metal as you can get because they're as far left on the periodic table as you can get. And so they are very, very metallic and they have low melting points. Okay. The other groups that we are concerned about, group 7A, which is all the way on the right-hand side, which is a nonmetal, we call halogens. And then group 8A are the noble gases. Okay, noble gases. So the halogens are very reactive. They usually are going to exist as gases and they're going to be hooked together. So your halogens are going to be kind of like that. 2 chlorines together, 2 iodines together. That's going to be how they are structurally when you find them in nature. The noble gases are going to be by themselves. Okay, so this is like argon and neon, things like that. They pretty much don't like to react with other things, and so they just kind of hang out as themselves. They're very, very stable, and so they don't like to react. But right next to them, group 7A are very reactive. Carbon is unusual. Carbon is has a unique ability. First of all, it can form 4 bonds, and it can join with itself. That is, it can bond with itself different ways. Like it can bond just carbon-carbon. It can have a double bond to another carbon. It can even have a triple bond to another carbon. So it can form all these crazy structures. And pure carbon can be in the form of a diamond, in graphite, like in pencils and lead pencils, and coal. Okay, so there are all these different forms that are pure carbon, and it's just how they are attached to each other. And that's all we're going to talk about the periodic table for now.